Hello, this is Janet and Rabia.
Welcome to Everest Physics Academy. In this video, we are going to explain Huygens principle and explain the diffraction phenomenon using Huygens principle.
Huygens' principle was introduced by the great Dutch physicist Christian Huygens in 1676 in order to explain the wave aspect of light. Now, we are going to explain Huygens' principle briefly, and in the next two slides, we're going to explain it in details using two animations. Look at the figure. S is a point source that emits a spherical wave. According to Huygens' principle, all points on a certain wavefront act as secondary point sources that emit spherical secondary waves called wavelets. In the figure, the blue points are some of the secondary point sources, and the blue arcs are some of the wavelets. These wavelets propagate with the same speed. At a later time, the new position of the wavefront is the surface formed by the tangents of the wavelets.
To understand Huygens' principle, watch the two following animations. In the first animation, a point source S completes one oscillation. Then a spherical wavefront moves through free space. As you see, the radius of the spherical wavefront increases with time. Now we repeat again the motion of the wavefront. The figure shows the wavefront at an instant t. Let W1 be the wavefront at an instant t1, where t1 is less than t. According to Huygens' principle, each point on a given wavefront acts as a secondary source and emits a spherical secondary waves called wavelets. At a later time, the new position of the wavefront is the surface formed by the tangents of these wavelets. As you see, the wavefront at time t is tangent to these wavelets. For clarity, only 4 secondary sources are drawn on W1 in this animation, which are S1, S2, S3, and S4. And each one of these secondary sources is a center of one wavelet. As you see, S1 is the center of this spherical wavelet. Similarly, at an instant t2, the wavefront is W2, and each point on W2 acts as a secondary source and emits spherical wavelets which are drawn by the green color. Now, let's start the animation. We can conclude that the wavefront at an instant t is tangent or remains tangent to the wavelets corresponding to all the secondary sources between the time 0 and the time t.
Focus, please. This is important.
In this animation, a rectangular plate AB completes one oscillation. Then a straight or a plane wavefront moves through free space. The figure shows the wavefront at an instant t. Let W1 be the wavefront at an instant t1, where t1 is less than t. According to Huygens' principle, each point on W1 acts as a secondary point source that emits spherical secondary waves called wavelets. At a later time, the new position of the wavefront is the surface formed by the tangents of these wavelets. For clarity, only 4 secondary sources are drawn on W1. Each one of these sources is a center of one wavelet. Look at S4. S4 is the center of this wavelet. Similarly, at an instant t2, the wavefront is W2. Each point on W2 acts as a secondary point source that emits spherical wavelets. Look at the green wavelets in the figure. The position of the wavefront at an instant t is the surface formed by the tangents of all the wavelets arriving at this instant from all the secondary sources located between AB and this position.
Now, we are ready to explain the diffraction phenomenon using Huygens principle. According to Huygens principle, each portion on a given wavefront acts as a secondary source of wavelets. The secondary sources in the slit are shown in this figure. Each point on the viewing screen receives light from all the secondary sources, so diffraction fringes are formed due to the superposition of the wavelets. At the center of a dark fringe, the wavelets superpose destructively, then they cancel each other. At the center of a bright fringe, the wavelets superpose constructively, then they add up together. So we can conclude that the diffraction phenomenon confirms the wave aspect of light. Thank you for watching. If you like this video,
Subscribe to the channel, hit the like button, and share.